think I know what you mean. Looking at number 3 on the review, I have to divide because the top degree is greater than the bottom degree. Actually, even if it's equal to, you need to divide. The only time I can synthetic is if it's just like x plus 2 or x minus 7. If it's more than that, I have to long divide. So 3x cubed. Remember to fill in the missing pieces there. So the lead term is what's most important. So what times x squared would get me to 3x cubed? 3x. Yeah, 3x. And people put this different places. I put it over the x to try to keep things lined up, but you don't have to put it there. Multiply it back, I get 3x cubed. That's a match because we forced that to be a match. Plus 6x. But I want to put that under the right place. And then I subtract those things. So those go away. I forced that to happen. I picked the 3x to make that happen. When I subtract these, I get negative 13x. And so now I'm thinking, what times x squared gets me negative 13x? That doesn't really work. So I've got this leftover parts down here, also known as the remainder. And then in 4th grade, you just said, oh, if I divide into groups, I have 3 left over, remainder 3. But later, sometime in middle school, you discovered you could do something else with this remainder. Decimal. Well, you did decimals, but we can't really do decimals here.
Fraction.
But we could do a fraction. So I've got 3x plus negative 13x over x squared plus 2. And now I need another sheet of paper because I'm out of space. Because how much calculus have I done on this problem? None. That's right. I've done lots of good algebra, but I haven't done any calculus yet. Okay? This is the same as this. Those don't look the same, but that's the same thing. This purple box is equal to this purple box. Right? They don't really look the same, but that's kind of like when you were in 3rd grade, if someone showed you 48 over 5, and that would be, what, 9 3/5? And someone told you those were the same thing, you'd be like, nah, those don't look the same.
They don't look the same.
But now you know, well, yeah, they don't look the same, but they are the same.
One's a Harry Potter term. Or almost.
10 3/4? 9 3/4. What's the Harry Potter terminal?
9 3/4.
Okay.
I don't get it.
Never read the books. Sorry.
I don't get it.
All right, so now I still have the calculus left to do. So we may as well finish this problem. Addition and subtraction, I can handle them separately. I don't do that with multiplication or division, but with addition and subtraction. So first part's easy, 3x squared over 2. Now that second part, I kind of don't like the 13, so I'm going to put the minus 13 out front. Make my life a little easier. I mean, I still have to deal with it, but I don't have to deal with it inside the integral. U sub, what would be a good choice for you? X squared plus 2, because du then would be 2x. Is that good news? Yeah, because I can go 2 and 1/2. Few of you might jump to the answer from there, realizing what's going on. Most of us are probably still slowing down here and saying,
inverse tangent.
No, not inverse tangent.
Can't believe you're trying to do
Hell.
natural law.
Although I see what you were looking at, but if you hold on, that's a good point because that does sort of look like inverse tangent.
Understandable.
But that would mean u is x and du is dx, and we'd have an extra x in the top. So yes, the denominator kind of looks like inverse tangent, but it didn't work when we got to there. So somebody recognized first that if we let u be the bottom, then du is the top. So how do we antiderivative 1 over u du? Natural log. So 13 over 2, natural log of u, x squared plus 2, and then plus c at the end. Good question. A bunch of people wanted to see that divide problem. On the divide problems, you may recognize this, but you're always going to end up with at least two pieces. The first couple pieces will be easy polynomials. The last piece will probably be a natural log. No, I shouldn't say that, because if this remainder had not had an x in it, then this would have been an inverse tangent problem. So.
Why do we always put the absolute value bars for natural log?
The incomplete answer to why we put the absolute value bars is that you can't take the log of a negative number. So to prevent that, we put the bars on there. Now that's not really the mathematical justification for it, but it's how I remember to put them on there. Although this one you could get by without them because x squared plus 2 is always positive. Okay, looking at the review, especially maybe the evens, we kind of breezed through the odds already, at least giving hints on them. Any of those evens look like, do you recognize what's going on all of them? I mean, I don't expect you to look at it and spout out the answer, but do you see what you would do to start the problem on all of them? Okay. 10 looks goofy. I'll grant you that. What do you think about 10?
I think that's a lot of signs.
What should we use for a, well, u's already taken. So, you could call it an x substitution. I'm going to call it a v substitution, but x would be fine. You just can't really use a u because it's already taken. So what could we pick for v so that dv would be in there somewhere?
Only one side of v.
Yes. Because if you pick sine to the 12th, then your derivative is going to be 12 sine to the 11th. Too much. So let's pick just sine of u for v. And then dv would be cosine. And that's really good news. So there's no plus or minus adjustment at all on that one. So dv, integral of 1 over u to the 12th, up v to the 12th. U's and v's. Maybe I should have done x's.
Yeah.
I can't integrate v to the 12th in the bottom. I really need to rewrite that as what?
Negative 12 on the top.
V to the negative 12. I mean, I can do that step mentally, but a lot of people, when they add 1, they mess that up. So, power rule. If I add 1, negative 11, divide by the new power. Plus c, but I'll put the plus c in after I multiple choice, they'd probably put that sine of u back in the bottom. But if you made it that far, you'd recognize that, I think.
Wait, so the plus c would go in the bottom with everything else?
It would not go in the bottom with everything else. It's just out there at the very end, the plus c is. What does number 6 look like? Inverse sign, but yes. 2 and 4 look like u substitution problems. How about some of the other stuff on the back? Okay with 13 and 14? We've been doing antiderivatives all day. Can you shift gear and go to derivatives? Do we need to do one of those? Let's see, or both of them? Let's see, I'm going to write the rule here before I get into the details. Derivative of inverse cosine is negative square root of 1 minus u squared times du. Okay, that's the general rule. Now for this one, there's a 7 out front, so that's just kind of going along for the ride here. So negative 1 over square root of 1 minus 2x squared. Make sure you square the 2 and the x. And then chain rule. The derivative of 2x times 2. And that's a fine safe stop, but that's a pretty straightforward question, so that might be a multiple choice type. Maybe, maybe not. There's not much to clean up with it. Just make sure you square everything that's supposed to be squared. Plus c on that?
No.
Why not?
Because it's a derivative.
That's a derivative, not an antiderivative. But you'd be surprised. People get, when we start doing both, they kind of get confused and they start putting plus c's on everything.
Derivatives were last.
Do you think of how like
Yeah. I was
Other questions from the review? Do you want to see the warm-ups so you at least see them, or just you can watch the video later? And
Are the warm-ups highly recommended?